A very good morning. We, the team of Strata Safe Providers, has taken this problem statement titled Renewable Energy Monitoring System for Microgrid under the idea of 25051. We have here mainly focused on the people who face multiple problems in the power system or the grid system, usually in rural areas. So we have built an IoT-based microgrid monitoring system designed mainly for rural areas. The idea is to make power supply more reliable, efficient, and sustainable using smart sensors, edge devices for edge detection, and AI. And next, we move on to the proposed solution. We have taken this as a proposed solution because our solution is sustained grid. It combines IoT sensors like ESP32 microcontroller and Raspberry Pi to monitor things like voltage, current, battery levels, and even the conditions of solar and wind systems. The data is sent using Wi-Fi, GSM, and LoRa. So if one network fails, the other can also take up the charge and work. On top of this, we add AI and cloud analytics to give smarter insights and a mobile app and a dashboard so that the operators can easily see the alerts, recommendations, and manage energy sharing fairly. And next is a technical approach. A technical approach here shows that how well our system is being done. The in the hardware layer, if you see all the IoT sensors like voltage, current, and battery, and checking out the weather, will combine all its data through ESP32 microcontroller plus a Raspberry Pi for the edge processing. The communication layer or the transformation of this data over distances is done by Wi-Fi, GSM, and LoRa. If in case of no internet or network facility, LoRa is being used. In the case of network or internet facility, Wi-Fi is being used. And analytics layer is like we here mainly focus on edge level reduction, and cloud we use AI and ML for demand prediction, battery health, and renewable forecasting. And the scalability is like a plug and play IoT kit, affordable for the people who are present in the rural areas and compatible with existing microgrids and the people who can easily access through it. And next is our innovation and uniqueness. It can predict energy demand using the past data. We usually collect the data from the previous pattern, and it works on a multiple communication mode, so it is reliable in the villages with the poor internet. And even if there is no cloud, it can still run on the local LAN, that is local area network for the transferring of data. And it supports community energy sharing, so excess energy from one home can go to the other, which ensures the equal sharing of the power, even uh, something has been excessive in one house can be redistributed. And next, we have added the sustainability feature, like we have integrated of integration and gamified rewards for the energy savings and all. And next is our architectural design. So it is basically the implementation of our system into the microgrids, which can usually detect the voltage, current, and the battery and the weather conditions through our microcontroller and sent via the Wi-Fi, GSM, LoRa to the cloud or the AI analytics. So that could be actually a real-time monitoring and be displayed in either the app or the dashboards for the operators to look into it. And next is a feasibility of a project. Feasibility is very practical because the hardware that we use are low cost and are easy implementation. And those hardwares have given a remarkable output in the other applications too. So it is affordable for the rural use, and it can reduce maintenance costs and energy losses. Since the app in the local languages and works plug and play, operators do not need much training. They can actually take up the app or the dashboards directly in their own specified language that is preferred for them. and it actually improves the efficiency around 15% and helps in rural electrification. And next is impact and benefits. It creates a real impact. It makes the microgrids more efficient and reliable. It saves cost and ensures uninterrupted power by detecting faults early. It also makes electricity management more accessible because everything is on a mobile app in the local languages. Communities get empowered because they can share energy fairly, and a model can easily scale up to many villages, supporting the clean energy adoption in the long run. So this is all about the feasibility and the viability that has been taken out from this project. And next is the research and the references that we have uh, gone through a lot of research papers that we have listed right here, that are being from the IEEE, and many of the journal papers we have even given that with the year of publications and its ID. And so, in short, our system, that is sustained microgrid, is not just about the monitoring. It is also about making rural power systems smarter, more reliable, and community driven. With IoT, AI, and hybrid connectivity, we believe this can really transform the rural energy management fairly, and we we feel this project will be reliable and implementing in all sort of rural areas and making this as the most efficient one for power energy saving. Thank you so much.